Okay, welcome everybody to the review session. We'll be talking about glaciers as well as the history of Antarctica lectures we've had, and I'll be providing some examples of possible quiz questions that could come from those topics. So the main focus of this review session will be lecture quiz number 2, but I wanted to go over what's coming up in class in terms of the upcoming due dates. So this quiz is out right now, and it is due on Sunday, May 23rd at midnight. And you have one attempt, which you can take a total of 30 minutes for. If you're watching this and you have DSP accommodations, those have already been taken into account. Just FYI. There's a total of 10 multiple choice questions and 2 short answer questions. And the material covered is the 2 glaciers lectures, 11 and 12, and then the 2 History of Antarctica lectures, 13 and 14. And then you will want to have seen the relevant clips of Encounters at the End of the World and Antarctica, a Year on Ice. And you will have at least wanted to have skimmed Little Shackleton reading, the excerpt from Shackleton's memoir. I am not going to be asking you super detailed questions about that, so don't worry about that, but just you will want to have read it, and it should give you a sense that there will be questions about the heroic age and about Shackleton on upcoming assignments. And there will not be any pre-midterm material on it, nor will anything from the climate change lectures for this week be on it. A week after lecture quiz 2, meanwhile, reading assignment number 2 is due. And that's very similar to the first assignment, except that this time you'll be writing about a scientific journal article or a history article if that's what you want to go for. And there is a lab due this Friday as well. The Antarctic Exploration Lab is due on Friday, May 21st. And a quick refresher again for the reading assignment. Assignment number 2 is about an article that is detailing research that is written by the scientists or by the historians themselves. And I am I suggest using the either it doesn't necessarily have to be GeoRef, that's just one good geology database, but searching in the UCSB library system has a search function where you can search for articles. And it's um, and it'll give you a sense of which ones are accessible to you because of whatever sharing agreements UCSB has with the publishers. And it'll also help filter your search out, and you won't get as many news articles, which aren't really the focus of this assignment at all. You can totally search for articles through Google, but you'll want to make sure that the article that you found is actually something from a journal that is peer reviewed and not just something and not an article that's written by people who are writing about somebody else's science or history research. And I'm very happy to suggest articles for you if you have a topic you think you'd like to go for. I'm very happy to look over articles for you. Your response is greater than 400 words. It needs to be greater than 400 words. That is, it's a one-page single-spaced document. And what you have to address this time are what were the research goals of the author or authors? What were their results and why are those results important? And then were the results what the authors were expecting? And then make sure you have a link to the article so that the TAs and I can find it. So any questions about assignment number 2? That is not due until next Sunday. I'm just putting this out here in case anybody gets a chance to get a head start. And we are getting pretty close to the end of the quarter now, because once reading assignment number 2 is finished, it'll be Memorial Day, and that is on the Monday of Dead Week. So it'll be time for the final exam after that. And after quiz number 2 closes, I'll start talking more about the format of the final exam and what to expect for that. So lecture quiz number 2 covers this material, and it's going to be very similar in format to the previous lecture quiz number 1. Everything except for the 2 short answer questions will be automatically graded. The short answer questions are meant to be short, just a couple of sentences each, and you want to follow the instructions as best you can and write as clearly as you can so the TAs know what you're talking about. So that doesn't mean don't waste lots of time writing and writing. And again, there will be nothing from before the midterm, so none of the lectures that were covered for the midterm, nor any of the videos or articles from before the midterm either. And also nothing from this week. So not lectures 15 and 16, not the climate articles. I'm not assigning any of the climate change stuff on this quiz at all. So any questions about the format of the quiz? Hopefully you've all taken lecture quiz number 1, so it will look very similar to that. It's again kind of a check-in between the midterm and the final. So I'll start with the history of Antarctica because we covered that last week and I haven't really done review on that yet. And during lecture 13A, we talked about how there's not an indigenous population in Antarctica. We talked about why that might have been because of Antarctica's isolation from other land masses. And then we jumped into the motivations that led Europeans to start exploring more of the globe or and doing other things as well as exploring, but um and how that brought people closer to Antarctica and how this mythical concept of a lost continent near the South Pole drove some of the exploration, such as Captain James Cook's second voyage to the Southern Ocean, and how discoveries such as the Drake Passage led, or how the discovery of the marine chronometer, which let people determine longitude at sea, how those discoveries and findings helped set the stage for subsequent Antarctic exploration. So, for the people that I put on this list here, like Magellan and De La Roche, you want to know basically why they're relevant to Antarctica. Magellan is relevant because he commanded the first crew to circumnavigate the globe, and he also mapped the Straits of Magellan, which became the most important way for people to cross from the Atlantic to the Pacific for many years, and that was how people traveled when they were going near Antarctica for a long time. Sir Francis Drake for being the first to postulate that there was water south of Tierra del Fuego and between South America and whatever was near the South Pole. John Davis for discovering the Falkland Islands, Bouvet for discovering Bouvet Island, and De La Roche for being the first to spot South Georgia. I probably won't ask a lot of questions about those figures, but they're people that show up as people who discovered the early little subantarctic islands, and it's a good indicator that the subantarctic islands were found before the continent itself because they're farther north and because they sometimes had resources people wanted, like seals, and they also often ended up where people ended up being stranded. Um, and it gave credence to this idea that that going into the Southern Ocean was dangerous, and indeed it is, and was. It still is, less so than it used to be. But for one thing, it took a long time for people to discover Antarctica because approaching Antarctica is really dangerous. Um, it, so anyhow, um, Captain Cook is one of the more prominent figures, and among his three voyages, well, one of them was chartered to follow up on on the reports of these islands, these scraps of land, to see if they would find a continent. And actually, the example question here is one that you might see just to give you context of. Well, it's a question that's meant to test you on what some of these people's focuses were and whether their entire career was about Antarctica or not. So I talked about several of Captain Cook's voyages because they involved mapping a lot more of the world and kind of set the stage for the heroic age. Um, but did he go to it? But how many times did he actually attempt to discover Antarctica or Incognita Australis? Were none of his voyages for that? Was one of them for it? Were two of them for it? Or were all three of his voyages for it? Or had Antarctica already been discovered? And in this case, you have a sense of what the answer is from stuff on this slide. But if you were going through this question on the midterm, or excuse me, on when you're taking the quiz, well, you know that he probably went to Antarctica, or he tried to go to Antarctica at some point. That's why I talked about him. Antarctica had not already been discovered, so you can roll that one out. And then I pretty heavily emphasize for the different slides on his voyages that he went to Antarctica or tried to go to Antarctica once. His second voyage was for Antarctica. His other voyages were for different things. And the first voyage, he definitely had the mythical lost continent on his mind, but he didn't try to sail into the Southern Ocean except on the second voyage. So, does anyone have questions about the pre-discovery of Antarctica portion of the course that they came with? Once Antarctica is discovered, a lot of its. Oh, I see a chat question. So yes, the answer would have been B. Sorry for not stating that more clearly, but the answer would have been B, one of them. In the meantime, so as we continue on, we get to the point where Antarctica is actually discovered. Bellingshausen, who is employed by Russia, sees it first, and then shortly afterwards, Americans and British sailors see it also, and Antarctica becomes public knowledge. And none of the figures that we talked about during Lecture 13B actually set foot in Antarctica, due mostly to the dangers of sailing wooden ships into icy waters. And some of the people that we talked about in this part of the lecture specifically went to Antarctica for scientific purposes. Others were there for economic reasons related to sealing and whaling. And that's one reason why the human presence was much bigger initially on the subantarctic islands, like South Georgia and Deception Island, than it was on Antarctica itself, because the subantarctic islands had fur seals, as well as places where they could build harbors, where they could build shipyards for going out to hunt whales and bringing their carcasses back and processing them. Whaling and sealing devastated the populations of those animals. It did also play a prominent role in Antarctic exploration because many islands were discovered, at least they became known to people. Their discoveries weren't necessarily published, but the islands became known to people over time because whalers and sealers started mapping out more of these islands. And it definitely put Antarctica and the islands around it on people's radar more. And it definitely played a role in people developing an interest in Antarctica for scientific and for specifically for exploring reasons. But it had a very strong negative impact on Antarctica's ecosystems as well. Um, so in terms of the people on this list, Palmer was one of the people there, largely for sealing as opposed to science. Waddell is an interesting example of somebody who was employed as a sealer but had scientific interests on the side, showing that the two don't necessarily always exist mutually exclusively. And that's a nuanced discussion that I think has to happen about the history of Antarctica and about how exploration and economics are linked. He was known for setting a new farthest south record and for mapping much of the sea that would later be named after him. Mr. Dumont d'Urville is mostly known for searching for the South Magnetic Pole and determining that it was indeed on land in Adélie Land. That's not where it is now because it shifts pretty quickly, actually. But um, then the first United States expedition was the Wilkes expedition, which was largely for science, but also set up to help look for possible more sealing and whaling grounds farther south. And the samples that came back from it ended up becoming a significant part of the Smithsonian Institution's early collection, which I think is really interesting. And then we also learned about the namesake for a lot of geographic features in Antarctica, James Clark Ross, who actually had some early success um, with modifying ships for Antarctic travel. He used ships with strengthened hulls that had been warships designed to deal with the recoil the from the volleys they were shooting. Those strengthened hulls actually helped protect the ships against the ice quite well. James Clark Ross got close enough to the Antarctic shoreline to see Ross Island and to see Mount Erebus erupting and to get a glimpse of the Transantarctic Mountains and to get a glimpse of the ice sheet inland. We don't really get onto the continent itself until the Heroic Age. James Clark Ross is about 50 years before the Heroic Age. A lot of this happens over Lecture 13B is mostly it's most of the 19th century, actually. It's up until the 1890s. The Heroic Age is a very concentrated window of time, only about 25 years, in which a lot more expeditions later begin. The other history was very much more spread out. And James Clark Ross went in the middle of the 19th century, and very few people would go to Antarctica after him to Antarctica proper after him until the end of the 19th century, when when people began to plan people began to experiment with technology and with means for surviving and getting around on the continent more, and when there was an increase in interest in actually going into the continent itself and trying to see if that was possible. Um, in the question here, which American sealer, among the first to spot Antarctica in the early 19th century, has an American research base named after him in the Antarctic Peninsula? A. Shackleton, B. Matthew Henson, C. Nathaniel Palmer, D. James Waddell, and E. Charles Wilkes. And it is indeed C. And that's one that should be hopefully simple enough to remember because Palmer Station is one of the stations we talked about. Now, the heroic age begins at the end of the 19th century. And for the history lectures in general, I would suggest watching the full videos. If you normally just look at the slides and don't watch the videos, I would suggest taking the time to watch the videos for the history lectures just because there's it might help you put some things in context better. And I think the slides by themselves come across just as a bit of a summary list, and it might be hard to figure out. It might be easier to figure out exactly why some of this is important if you watch the whole videos themselves. So some themes to consider for the heroic age are: why did exploration speed up? Some of it had to do with simply more people being near Antarctica, as the economic boom of the California gold rush came into sway, and many more people started to migrate towards the west coast of the United States, and a lot of those people did so while going around South America. And then you want to think about the goals of the different expeditions that were put together as interest in Antarctica increased, and as more people and more governments began to fund expeditions to go to Antarctica. Um, you want to think about what their findings were, like how Scott, before he went to the South Pole, found penguins. He observed penguin colonies, and his scientists made sketches and brought back observations of these penguins, and the degree to which the heroic age explorers opened Antarctica up, and the various hardships and endurance shown, like during Shackleton's escape or during Douglas Mawson's being marooned in Antarctica. The example question is kind of a sort of a thematic and why is this important question, as opposed to one about specific historic figures. And it is leading into the heroic age and during the gold rush, how did most people travel from the Atlantic to the Pacific? And the heroic age, remember, is 19th century. So the possibilities are the Panama Canal, the Suez Canal, the Northwest Passage, the Straits of Magellan, or the Ross Sea. And a couple of these you can roll out, because if you remember that the heroic age was 19th century, then some of these, like the Panama Canal, was that built yet? Or no, the Panama Canal was not built in the mid 19th century, so that's one you can rule out. Suez Canal has nothing to do with the Americas, that's over in Egypt. The Northwest Passage is related to the Arctic. That's people trying to go from Greenland to Russia, basically. The Straits of Magellan. Well, Magellan went around South America, or he went through South America in a sense by going between the main body of South America and Tierra del Fuego. And then the Ross Sea is actually down in Antarctica itself. So this is one where you want to think about roughly when this happened in history, like 19th century versus modern day. And then you want to think about what is where. The Ross Sea is an Antarctic Sea. That wouldn't really make sense for people going from the Atlantic to the Pacific. It's the Straits of Magellan in this case. Any questions? And this is not an exhaustive list here, but this is a good summary of some of the people who come up more than once and who I'm very likely to ask you questions about. Because there's a lot of people and a lot of expeditions that I talked about, but I did my best to explicitly say why each was important and why it was relevant. And so someone like Robert Falcon Scott, who took two separate trips, he first tried to reach the South Pole and still came back with a lot of observations about penguins and about the Transantarctic Mountains. And he would later attempt to go to the South Pole and make it this time, but then not survive the trip back. Um, and Amundsen, who had previously been on the Belgian expedition, is most known for his successful trip to the South Pole, in which he was able to survive. He traveled much more lightly than Scott, who was a heavy traveler who brought everything. Amundsen tried to travel as light as possible and relied on dogs. And I bring up Douglas Mawson because his expedition stands out for ambition. For one thing, trying to establish communication between Antarctica and the outside, which is now something we take a little bit more for granted because people at McMurdo can talk to people outside of the continent, but that was very hard to do for a long time. And so the heroic age is when they first attempted to establish communication between Antarctica and elsewhere. And when they first tried to build bases, which didn't go very well. The first attempt to establish communication lines and build bases in Antarctica just didn't go that well, frankly. Mawson himself survived, but the rest of the men who went with him on on his trek into the continent perished, and he ended up having to spend an extra winter in Antarctica because of how late he got back to the ship landing point. And Mawson had also gone to Antarctica with Shackleton when Shackleton went on his first voyage on his Nimrod expedition, in which Shackleton also tried to reach the South Pole and didn't quite get there, but managed to summit Mount Erebus and make some other important observations in the process. Um, Shackleton is best known for his second voyage, which was the Imperial Transantarctic Expedition, in which he tried to cross the entire continent but never even reached one side of the continent because his ship, the Endurance, got stuck in the ice and the ship was eventually lost. And in retrospect, that voyage is now best known for the successful and harrowing and really almost seemingly miraculous escape from the ruins of the ship to um, eventually to a whaling station on South Georgia Island, um, which involved a lot of time spent in a lifeboat, and a lot of his men just having to stay behind on one of the more remote and derelict sub-Antarctic islands, while Shackleton and just a handful of his people tried to sail a little lifeboat over to South Georgia through the very stormy Southern Ocean. And that's one reason why I assigned the Shackleton reading, because it's I think it's important to look at firsthand accounts of these and to get a sense of exactly what they were going through and why this has been so heavily studied. He's also known for trying to go to Antarctica one last time, and dying before he even left South Georgia, and that's symbolically sort of seen as the end of the heroic age. That was also around the time of World War One, and so the World Wars kind of brought an end to the heroic age. And we'll pick up with another lecture next week, actually, that goes over the 20th and 21st century history of Antarctica. So the example question here is one of the more specific ones you might see. And so for some of the other expeditions, takeaways might relate more to the fact that, say, they took photographs, or like the Dragalski expedition, it might be more known for the fact that they took aerial photographs than for necessarily the name of Dragalski himself. Um, but in this case, the question is, which heroic age Antarctic explorer, during his race to the South Pole, used dog sleds as his main method of transport and was able to travel light and move relatively quickly? And again, I talked about this a moment ago, but the answer will be Roald Amundsen. Roald Amundsen is someone I linger on a fair bit in lecture, and I talk about the dog sleds and how he was the light traveler to the South Pole a fair bit. Um, and hopefully, two names should jump out to you: Scott and Amundsen, because those were the two people involved in the race to the South Pole who actually got there around the same time, even though Amundsen got there first. And you want to think about their contrasting styles and which helped, and think about which was more successful and which actually got the person to the pole faster. As for some of the others, Palmer is not a heroic age figure, so you can rule him out. And I didn't talk. I threw the leader of the Japanese Antarctic expedition in there, kind of just for funsies, and because that's might not be a name that jumps out to you, but it's like, oh wait, you can think, okay, there was a Japanese expedition, but they didn't actually get to the South Pole, so that's not relevant. And Shackleton never got to the South Pole either, and he's more famous for other things than this. So, questions before I talk a little bit about what to look for in the videos and the readings? So for the videos, take notes on what you find interesting, and also think about the people they interview in Encounters and in A Year on the Ice, and think about what their role in Antarctica is, what they're doing there, whether they're scientists or whether they came to Antarctica sort of with to work, but then also kind of out of an interest in Antarctica, even if it's not necessarily one in doing the science itself. Um, And again, for the Shackleton reading, you can skim it. Make sure that read it and make sure that you've read it, but you don't need to worry about taking detailed notes or expecting me to. I'm not going to be asking you long essay questions about that. Remember that the quiz only has two short answer questions, something on the realm of 2 3 sentence long answer. So you're not going to be writing essays about this. Are there any questions about the history of Antarctica before I go back to glaciers for a couple slides? because glaciers are covered on this quiz as well. I did previously host a review session on glaciers, and so you've seen some of this stuff before. But remember how that in the first glaciers lecture, we talked about how glaciers fit into the overall water cycle, and then some physical varieties of glaciers, like continental versus non-continental glaciers, and how you have, within continental glaciers, you have the larger ice sheets and the smaller ice caps, and then you have stuff like alpine glaciers, outlet glaciers that are defined by their shape and what the terrain is like around them, whether they're flowing through a valley or whether they're, in the case of a Piedmont glacier like this, terminating as the glacier flows out in a more open plain, spreading out after it's been squeezed through a more narrow valley like you have here. And the example question here relates to understanding some basic important principles about some of these glaciers. In this case, a tidewater glacier. And so the question is true or false. A tidewater glacier will flow faster at high tide and slower at low tide. So is that true or false given what you know about tidewater glaciers?
True.
It is indeed true. Correct. And even if you don't instantly remember what a tidewater glacier is, that's something you can figure out with a bit of logic because glaciers flow faster when the friction is less and rising tides actually lifts the glacier up. And that if the glacier is lifted up, that lift actually reduces the friction that the part of the glacier that's farther up experiences with the rock underneath it. And it really is worth considering that what happens at the end of a glacier is going to have some effect on the glacier further upstream, so to speak, because glaciers do kind of function like streams. Um, they function as streams in Antarctica because there's really not much liquid water present in Antarctica at any given time. Yes, there are subglacial lakes, but not very many of them. All things considered, and it doesn't really take up volume-wise nearly as much volume as do the glaciers themselves. So glaciers flow and the fastest part of glaciers flow as ice streams, and ice in the center, as well as ice that's at the surface of a glacier as opposed to being deeper down and possibly in contact with the rock. Those parts flow faster because there is less friction. And so we talked about some of the important features related to glaciers, subglacial lakes, ice falls, and then what happens to glaciers in the ocean, how Antarctic glaciers continue as ice shelves, and how ice shelves break into icebergs, and how ice shelves, which are continuations of the glaciers, are different from sea ice, which freezes directly from ocean water. So in the example question here, in Antarctica, glaciers continue to flow outwards and over the sea as ice shelves when they reach the ocean, because blank, which process of glaciers is still going on at the coast? So this tests you on whether you know these definitions. So the possibilities are calving, sublimation, accumulation, ablation, and albedo. So which of these completes the blank the best in this case? Indeed, the answer is C, because glaciers accumulating mean that snow is piling up and the glaciers are overall getting bigger. And that is really what forms the ice shelves in Antarctica. The glaciers are still growing on the coast. Ablating means the glaciers are breaking up, and like the glaciers do eventually break up out over the sea, but that's not really what I'm talking about here. That's further out in the ocean, and I'm talking about right along the coast. Albedo doesn't have anything to do with this. Albedo just refers to whether a glacier reflects light or not, which it does. That's not really super relevant to this. Calving means the glacier is breaking up, and that happens out over the ocean. Icebergs don't form right along the shore in Antarctica. They form way out over the ocean at the edges of the ice shelves that extend, again, quite a bit over the ocean. And it's why Antarctica kind of looks puffy in a map. If you look at a satellite image of Antarctica, you don't really see defined scraggly coastlines like you do in elsewhere in the world, like in Norway or along California. You just kind of see this. You just kind of see this ice extending out from the continent and making this circle around the continent, basically. Any questions? There's another distinction with glaciers that is important, and that's between warm base and cold base glaciers. In cold base glaciers, the temperature increases as you go from the surface to the base, um, and cold base glaciers are most glaciers in Antarctica. The reason the temperature gets higher as you go down is because the sun in polar regions heats the surface very ineffectively, and the glacier is actually more effectively heated by the heat of the Earth at the base. However, it's still not enough to cause melting. Um, the important thing with glaciers, with warm versus cold base glaciers, is that in glaciers that you find in mountainous areas of more temperate latitudes, the the pressure the pressure in the glacier is high enough. Um, Pardon me. Sorry. The glacier gets warm enough that it's about the temperature of the ice throughout the glacier will be approximately following the trend um, of the pressure melting temperature of the ice, meaning that you'll have some ice present and then some meltwater present as well. In glaciers that are outside of Antarctica, you'll have a lot of meltwater, comparatively speaking. And the consequences of that are that these glaciers tend to flow a little faster in some cases and also tend to experience more movement by basal sliding because there is more lubrication by the meltwater. Antarctic glaciers don't tend to have very much meltwater because the air temperatures are so cold, because the sun in the polar regions does not it's hitting Earth at an angle and providing comparatively little solar radiation. So you've hopefully seen this diagram a few times now in the lectures and in the review sessions. And let me know if you have any questions about interpreting either of this diagram or about cold and warm base glaciers. The big thing to remember is that this is a separate category system from continental versus non-continental, and the distinctions between Piedmont and Valley and Alpine. Those are about the shape of the glaciers. This is about the thermal properties of the glaciers, and there are two separate ways to categorize them. We went on to talk about how glaciers move and about ice mass balance, how glaciers are balanced between accumulation and ablation. Glaciers can either move as a single cohesive mass, which is a lot more common in warm-based glaciers, or they can flow like a very thick fluid downhill. Under a lot of stress, glaciers will break up and form crevasses, and this will happen in response to sharp turns or tough ground or mounds, and crevasses come and go over time. Um, so one question I could ask you is, warm-based glaciers with more meltwater at the base experience more movement via blank, referring to which process? So the possibilities are respiration, plastic flow, decoupling, basal sliding, and abrasion. And indeed, the answer is D. And that's really one of two that are relevant in this case, because respiration has nothing to do with glaciers, really. That is referring to cell respiration. Plastic flow is one possibility. That's a way that glaciers move. Is it the correct way that glaciers move? Well, no. Um, if there's more meltwater, you're going to get more basal sliding, as you correctly picked. So you can rule out decoupling, because that is just me throwing in a technical sounding term that doesn't have anything to do with glaciers to test you on that, or just to help you rule that out. And then abrasion refers to how glaciers erode, how glaciers break down the rock underneath them. So hopefully you can at least narrow it down to basal sliding and plastic flow, and then you can think, okay, which of those makes more sense? Do glaciers warp and rearrange when there's more meltwater, or are they going to slide? And more meltwater and more lubrication means sliding. Now, speaking of erosion, the last thing we talked about with glaciers was how glaciers erode the rock underneath them, and how that's the most dominant type of erosion in Antarctica, um, and how glaciers are extremely effective removers of material. Glaciers clear everything out of their path. They mostly grind material into a very fine powder, making till. That till is going to have chunks of larger rock, though, because the glaciers sort of bulldoze larger boulders out of their way, and they also pluck pieces of rock. Um, Often, when glaciers flow over more resistant rock, that causes a pressure increase. When the pressure drops, that will actually cause any meltwater that's formed to freeze, and the ice freezes to the less resistant rock that the glacier is passing over on the other side of the mound, and it'll pull the pieces of rock with it and mix those plucked pieces of rocks in with the just the shavings, basically with with the stuff that the glacier is removing by abrasion. So glaciers do two things: they abrade or grind underneath them, and that makes polished surfaces as well as striations and grooves from single direction flow, especially when you have glaciers that are confined to valleys and flowing most intensely in one direction. Glaciers will also pluck, though, under the circumstances that I just talked about, when you have the pressure change from the glacier flowing over um, a more resistant mound, and that will leave behind shatter marks from the bits of rock that have been stripped away. And then we went into talking about the products of erosion, how you have ice rafted debris, the stuff carried on the surface, and then till, which is made of a combination of mostly really fine grained sediments, but then some larger rocks thrown in. And this hill that forms at the end of glaciers where they end on land, not as commonly in Antarctica, but sometimes you'll see this in the dry valleys, um, and very common in glaciers outside of Antarctica. This is the till that has been pushed out by the glacier, and this is where it gets deposited, where the glacier is ablating and ending. And you have some other interesting products of glacial erosion that affect the landscape. You get outwash, which is the sediment carried by the melting water, and that creates a really interesting pattern called varves, in which the sediments in a lake will show light colored layers when there's a lot of glacial outwash in the summer, and then darker colored layers in the winter when the glaciers aren't melting as much and when it's mostly just a thin layer of organic lake sediments. Scientists actually study this to study climate patterns, and I'll talk about this in lecture 16 that's being released today, but that's not a topic for quiz number 2. Then you have glacial flour, which is the ground up quartz that you get floating in the ocean and giving it a turquoise color in areas with lots of glaciers. And then you just have glacial erratics, bits of boulders that have been left behind by glaciers that have since melted on land, and then drop stones when glaciers that extend out over the sea, especially when you have significant ice shelves forming, as they break up, they drop any rocks that are on the underside of them down to the seafloor, and they end up being preserved in the sea sediments, in the sedimentary rocks that form from the muds on the ocean floor. And you'll have these nice layers of sedimentary rock formed from ocean mud, but there will be this boulder plopped into them seemingly randomly, and that is telltale evidence for the presence of glaciers, and particularly for the presence of glaciers at sea level in the rock record. So I've talked about erosion in Antarctica, but I've hinted at the fact that erosion in Antarctica is different from elsewhere in the world because different processes dominate. So in the example question, I ask you, outside of Antarctica, most erosion occurs via blank or what process? And the agents of erosion that I list here, or possible ones, are isostasy, liquid water, glaciers, wind, and biological activity. And you want to think about, what have I talked about glaciers replacing in Antarctica? And the answer is indeed B, liquid water. Liquid water outside of the polar regions is by far the largest agent of erosion. Rivers carve canyons, rivers carve valleys. That process is being taken over by glaciers in Antarctica, where you have solid rivers of ice replacing liquid water. Isostasy doesn't really have much to do with erosion. Remember, that refers to buoyancy in the mantle. Um, we don't have tons of glaciers outside of Antarctica, certainly not here in Santa Barbara, where I am presently. Wind plays a role, but I've hinted that wind doesn't, that like in Antarctica, wind plays a pretty small role, and elsewhere, water plays the largest role. Wind does do things, but much more slowly and less efficiently than water. And biological activity, you just kind of want to think about like how much gets removed by worms burrowing or even by humans mining compared to the sheer amount that's been carved by, say, the Colorado River cutting through Grand Canyon. Um, Anyhow, that's a potential question I could ask you about this. So any questions about erosion? That is basically all of the topics that could come up on lecture quiz number 2. I did want to mention a few things about Lab 7 if you haven't already done it. But the lectures that I list here, lectures 2, 13, and 14, are definitely worth reviewing. And 13 and 14, you should definitely look over again because those are on lecture quiz 2. But it's also helpful for the lab because the lab is focused on examining maps and the routes of several Antarctic explorers, including Captain Cook, whose second voyage is talked about in lecture 13. And then lecture 14 details the heroic age explorers like Amundsen and Scott and Shackleton and Mawson. Mawson doesn't really come up on the lab, I guess, but most of the other people outside of Captain Cook who come up on the lab related questions are people that we talked about in lecture 14 from the heroic age. And then lecture 2 is worth reviewing as well, because that's where we cover latitude and longitude and talk about concepts like the Antarctic Circle, map projections, and how map projections can be distorted, and how we've made special polar projections to study Antarctica, and then topography. And the TAs also have some good information in the presentation for Lab 7 under the Files Needed section, and it's worth reviewing that, as well as reviewing their document from Lab number 1 when you did a MAPS lab further back. So again, the labs I don't explicitly test you on for the quiz, but I'm including this here just to highlight connections between what you learned in lecture and what you're expected to do for lab this week. And that is all I have for you for this review session. Thanks to those of you who came, and thanks for being patient with the rescheduling. And let me know if you have any questions. I'm leaving the recording on for just a moment, so you are being recorded. If you have questions that you don't want recorded, I will be sticking around until 4. Also, Maki says hi. She's picked a good place for the camera. Okay, I am going to shut the recording off, and thank you all for coming, and good luck on the quiz to those of you who came today, and also those of you who might be watching this as a recording, because I will upload this.